So here is another problem from JEE Advanced 2017, wherein it is asked how many 3 cross 3 matrices M are there with entries from this finite set consisting of the elements 0, 1 and 2, for which the sum of the diagonal entries of M transpose M should be equal to 5. So this is a problem which involves some simple concepts from matrix algebra, and the rest of the things is pure combinatorics. So just have a look at what exactly would be M transpose M. So if we take the elements as say A, B, C, D, E, F and G, H, I. So if this is the matrix M that we are taking, then let's see what is M transpose M. Okay, so M transpose M would be equal to, so what is happening is, if let's not bother about the entire matrix, but rather just write down what are the diagonal entries, because all that is mattering is the sum of the diagonal elements. So you have the look at the first diagonal element, it will be A square plus B square plus C square. That would be the first diagonal element, plus C square. And you have a look at the second diagonal element, it will be D square plus E square plus F square. And finally the third diagonal element will be G square plus H square plus I square. Okay, so what it means is, if you take the sum of the diagonal elements of M transpose M, which is also known as the trace of a matrix, it is simply equal to the sum of the squares of all the elements of this matrix. Okay, so M transpose M, that is the trace of M transpose M, sum of the diagonal elements, it is equal to A square plus B square plus C square plus D square plus E square plus F square plus G square plus H square plus I square. Okay, now what is it mentioned, that this sum should be equal to 5, and what are the all possible combinations we need to find out. So as such, if there is nothing more given, it would have been a difficult problem, but then we know that the only values which A, B and C can take are from this small little set consisting of 0, 1 and 2. So let's have a look at 5. How can it be written? So 5 can of course be written as 4 plus 1. Okay, and why is this the 4? I have written the 4 is because it can be written as 2 square. 2 square plus 1 square. So which means there is a possibility of choosing one of these elements to be 2 and one element to be 1 and all the rest to be equal to 0. Okay, and how many possibilities are there? So number of possibilities of choosing this thing, that is choosing one element to be 2 and the other element to be 1 and remaining everything to be 0, it is equivalent to arranging two objects in 9 positions, right? So it is be simply equal to 9p2, whose value is simply 9 into 8, right? So this is 9 into 8, which is 72. Okay, so we have obtained the value of the first case. Now there is another case which we should not forget, that is if we exclude the 2 out of the scenario. So then we can write it as simply as 1 square plus 1 square plus 1 square plus 1 square plus 1 square. Okay, which means that out of these 9 numbers, we are assigning the value 1 to exactly 5 of them, and the remaining all of them will get the value equal to 0. So again, an obvious thing in combinatorics, we know its simple value is equal to, so the number of possibilities here is simply equal to 9. We have to choose 5 of the 9 things. Okay, so let's see what is its value. It is equal to 9 factorial upon 5 factorial times 4 factorial, which can be written as 9, 8, 7 times 6 upon 4 into 3 into 2. So this happens to be, you can cancel out, and then we get 63 times 2, okay, which is 126. 126. So let's see what is the final thing that we get. We obtain the value as, so here we have 72 plus 126 and the total value. So therefore the answer to this problem is equal to 198. Okay, so it's a good problem which involved simple matrix algebra but a decent amount of combinatorics.